Hi, I'm Roland Minton. These are some of my favorite math stories. In this episode, mathematics is infinite. We'll look at infinite series, focusing on a special one created by the subject of the book and movie, The Man Who Knew Infinity. Along with derivatives and integrals, infinite series is one of the pillars of calculus. Unfortunately, it's typically the least popular of the three. I hope that at the end of this episode, you'll be puzzled by its lack of popularity. Let's look at a simple example to orient ourselves. Here, the large Greek sigma means sum, and we're putting in the numbers 1, 2, 3, and so on into the formula 1 over 2 to the n, and adding up all of the values. With n equals 1, we have 1 over 2. With n equals 2, 1 over 2 squared, or 1/4. N equals 3, 1 over 2 cubed, so 1/8, and so on. Since there's no way to actually add up all of these numbers, we deduce the answer by seeing the pattern as we add more and more terms. First two terms, 1 plus 1/4, we've got 3/4. Then adding on the 1/8 gets us to 7/8. Adding the 1/16 gets us to 15/16. 3 over 4, 7 over 8, 15 over 16. Do you see the pattern? The denominator is a power of 2, and the numerator is 1 less than the denominator. So the next partial sum would be 31 over 32, then 63 over 64, with the values getting closer and closer, converging to 1. So we say that the infinite series equals 1. Most infinite series do not produce such a nice pattern, and calculus focuses on rules needed to decide whether the series even has a value or not. For example, 1 plus 1 plus 1 plus 1 and so on would not converge to any number. The running total keeps growing and diverges to infinity. A series that gets the spotlight in its own episode is known as the harmonic series, and it surprises most people. The harmonic series is 1 plus a half plus a third plus a fourth plus a fifth and so on. It looks like it ought to add up to some finite number, but, well, spoiler alert, we'll see in the harmonic episode that it also diverges to infinity. Infinite series can be tricky. Srinivasa Ramanujan lived from 1887 to 1920. He was a largely self-taught mathematical genius who filled notebooks with complicated formulas. From his clerk job in Madras, India, Ramanujan sent large samples of his results to various English mathematicians. The great G.H. Hardy was the only one who recognized that genius. Hardy could not see why some of the results were true. Ramanujan had only a vague concept of mathematical proof. Formulas that just made sense to Ramanujan required proof for Hardy to accept them, though he said Ramanujan's results, quote, must be true, because if they were not true, no one would have the imagination to invent them. Ramanujan came to England and collaborated with Hardy, a story told in The Man Who Knew Infinity movie and book, and one that touches on many deep philosophical questions. I highly recommend the book and the movie, but be warned, the ending is not happy. So, what type of formula did an isolated young man come up with his own in India? Well, there are over 3,000 of them, many of which opened up new areas of research in mathematics once they were known. The one I'll explore here is the infinite series 2 square root of 2 over 9801 times the infinite series of 4k factorial 1103 plus 26,390k divided by k factorial to the 4th, 396 to the 4k. Wow. Don't turn this off. It's not that bad. The exclamation point references the factorial function. So 4 factorial is 4 times 3 times 2 times 1, which is 24. The first term in the series uses k equals 0. There's 0 factorial in the numerator and denominator. For various reasons, it turns out that 0 factorial is equal to 1. That's a little weird, but let's go with it. On top, we have 1 times 1103 plus 0. On the bottom, we have 1 to the 4th times 396 to the 0. And you may remember that any non-zero number raised to the 0 power is 1. The denominator is a complicated way of writing 1, and the entire fraction equals 1103. So multiply by the stuff out front, and we have 2 times 1103 square root of 2 over 9801, which equals, well, that number doesn't look especially familiar. But if we do the reciprocal 1 divided by that, we get 3.1415926, which looks a lot like pi. The first 7 digits are correct. In fact, it's been proven that the series sums to pi and converges very rapidly, making it one of the most efficient ways to compute digits of pi. Let's see how this works. K equals 0 gives 2 square root of 2 divided by 901 times 1103. We just saw that. We're going to add then k equals 1, where we've got 4 factorial times 1103 plus 26,390 divided by 1 times 396 to the 4th. So we do that, we do 1 over that, and you get the first 16 digits of pi. Add in another term, and you get the first 24 digits correct. Each term added gives you an additional 8 correct digits of pi. And this was discovered by a young man working by himself in India way before computers or even decent adding machines. It's hard to believe. The episode Cinematic talks a little bit more about Ramanujan and his deep connections to numbers of all kinds. Otherwise, the choices of 1103 and 26,390 and 9801 and 396 in this formula are incomprehensible. It's mind-boggling to think of the genius of Ramanujan, the man who knew infinity, whose short life was as influential mathematically as any in history.